Hi guys, so today we're going to go over the equations of an ellipse. So just note that there's two of them. One has a vertical major axis and one has a horizontal. And the way you would tell is that the larger denominator, which is a, would either be under the x for horizontal or under the y for a vertical. You'll know that a correlates with the major length, which is the longer length of the ellipse, and b correlates with the minor length, which is the shorter value. Now, one thing I do want to note is keep in mind an ellipse is adding. So it doesn't matter if this comes first or this fraction comes first or this fraction comes first. It's adding. It's like saying 1 plus 2 and 2 plus 1. It's going to give you the same value. So don't think about the order of them, but more so where the largest denominator is to tell if it's horizontal or vertical. For a hyperbola, you could, but not for an ellipse. Okay, so I just want to go over a couple of the basics on the ellipse. So if it has a horizontal minor axis, everything is happening horizontally. So meaning the distance from the center to each focus is what's called, is the value of c. So the distance from the center to the focus is c. And we'll get more in detail in that after we just go over the basics. But everything is happening horizontally, whereas if it was a vertical, everything would be happening vertically. So the focus is still the distance between the center to the focus would be c, but everything is happening vertically if it's a vertical major axis. Also keep in mind the length of the major axis is notated by the distance 2a. So that's from one vertex to the other vertex. One vertex to the other vertex has a length of 2a. A itself is the distance from the center to the vertex. So a is half that distance. So keep that in mind. It is always half the distance of the major axis. Whereas the minor axis, it has a length of 2b. And that means since b is from the center to the vertex, so the center to the vertex, that would be half of the minor axis. And also in an ellipse, a is always greater than b. Last thing just to put down in your notes is the eccentricity, which is the concept of the ovalness of the ellipse. It's notated by the formula E equals c over a. And from here, we're going to apply all of this content to a problem. So I'm just going to graph these given vertices. So negative 2, 0. And 4, 0 are the vertices. There's an eccentricity of square root of 5 over 3, which remember is the formula c over a for eccentricity. So we know the value of c, we know the value of a. Now, from here, since the vertices are going to be on the end horizontally, there's a relationship. They're moving horizontally. That means that I have a horizontal major axis. Covertices are the endpoints of the minor axis. So we know which equation we're going to use first, because remember there's two. So also remember that we're just finding the values of the variables that are not x and y. Again, x and y represent any point on the graph itself, so any point on the ellipse itself. So we just need to find the center, the value of a, and the value of b to write this equation. All right, so let's start it off with the center. You know, we did that for the circle. The good thing is that you have these two vertices or endpoints, x1, y1, x2, y2. But since you know that everything's happening horizontally, you can also just kind of count where the center would be as well. So either way that works for you is fine, whether you do it through midpoint formula or whether you just count it. For the circle, we used midpoint formula, so I'll just show algebraically how to do it as well. So remember center, you're using midpoint formula, x1 plus x2 over 2, and y1 plus y2 over 2. And that would give me negative 2 plus 4 over 2, and 0 plus 0 over 2, which would give me negative 2 plus 4 is 2, 2 over 2 is 1, 0. So that's where my center is. That's H and K. All right, so we have H and K. We need to find A. There are two ways to find A here. You have a major axis. You actually know the length of the major axis, so A would be half of that. And again, you can count that the major axis, the distance would be 6. Half of that is 3, which we also already have under our eccentricity. So either way, you could have done that. Now, how do I find B? Remember the formula that if you're given the values of A and C squared equals A squared minus B squared. So B is just the distance from the center to the covertex, which represents the minor axis. So from the center to the end on the minor axis, from the center to the end on the minor axis, both ways. So from here, we know that C is square root of 5. So square root of 5 squared equals A squared. I know A is 3. 3 squared minus B squared. The square root and square get rid of each other, leaving you with just 5 equals 9 minus B squared. So I'm going to subtract 9 on both sides. I'm also out of room, so I'm going to move up here. Negative 4 equals negative B squared. I'll divide everything by negative 1, giving me 4 equals B squared. And to get rid of this square, I square root it. And that'll give me B equals 2. Again, B represents a length, so when I square root, I'm only using the positive value. So filling in everything that we know, H, K, A, B, we have x minus 1 squared plus y minus 0 squared. Now, if it's y minus 0 squared, y minus 0 is going to give you y. So you can just write this as just y squared. Over a squared. A is 3, and y would be over b squared. B is 2, equals 1. You can square the values. I prefer to leave them this way, but you could rewrite this as 9 and 4. Either way that you see it is fine. All right, guys, I hope this helps.